Today's video will cover two learning targets. The objective is that you can define the terms related to matter and that you can also properly classify substance according to their different properties. Okay, so your goal is to learn the terms so that we can use them in class tomorrow. So to start out with, we say chemistry is the study of matter. When it comes to what is matter, we're talking about anything that can occupy space and things that have mass. So when you think about matter, matter covers pretty much everything. There's some little gray areas of whether things are matter or not, such as light, energy, heat. Most of those things would not be considered matter since they either don't have mass or don't have volume. Now when we talk about mass, we're talking about how much matter something has. Okay? The term you're most commonly used to hearing in relation to mass is the term weight, and weight is not the same thing as mass, so be aware of that. Mass is something we're going to measure in grams, and that actually measures the amount of stuff that a substance has. Weight is the amount of stuff as it relates to the gravity of wherever you are. So again, your weight in space is different than your weight on Earth because it's your mass, your stuff, related to gravity. Okay? Your mass in space wouldn't change unless you, I don't know, lost an arm or something, but your weight does change because it has a relationship with gravity. When we talk about anything that occupies space, the measurement we're talking about is volume. Okay? The container or the amount of space that something takes up is measured by how much volume it contains. Now, when we think about matter, all matter is made up of the elements from the periodic table. But if you look at the periodic table, there's only, 116, 120 elements. Now, we keep making new elements, and I'll talk about that later. But in all honesty, we're limited by the ability of these atoms to stay together. But life is obviously more complicated than just those 120 elements. Okay? That's not all there is. So what else can these elements do beyond just simply being single elements? Okay, what other classifications of matter are there other than just elements? Elements can come together and they can do one of two things. They can chemically combine with one another. And what that means is that two or more elements, okay, so you need at least two, are coming together to make something new. Okay, they're actually coming together and no longer being separate different things. Somehow they're combining. They're bonding is the term we use in chemistry. So they're being made into a new substance. You need energy to do this. The term we use for when two or more elements come together is a compound. This is still considered a pure substance, which we'll talk about in a second, but it's a chemical combination. The other thing that two elements can do is they can come together with a physical combination. And that's when two or more things come together to make something new, but you can separate them pretty easily. They don't actually chemically bond with one another. They keep their own inherent properties separate from one another. Okay, and the term that we use for physical combination is a mixture. Whenever we mix something together, but the two things don't chemically come together, it's considered a mixture. So the way we make life more complicated than just the elements are those elements chemically combined or are they physically combined. Now, in terms of just definitions, when you're talking about an element, what is an element? It's a substance that has a constant composition and you can't break it down ever. Okay? When you have carbon, you can't take carbon and break it down into smaller pieces. If you break it down into smaller pieces, you're actually changing the subatomic structure and making it into something new. If you have a compound instead, where you have those two or more elements chemically coming together, those also have a consistent composition where it's uniform, but you can break them down potentially into their elements. Like water, which is H2O, can be separated into hydrogen and oxygen by decomposing the two pieces. Okay. Is it easy to do? No. Right? If you heat water on your stove to really hot, you don't break it up into hydrogen and oxygen, you heat the water up into water that's a gas. It's not always easy to separate a compound into its elements, but it can be done. So these two examples, when things are coming together in a chemical way, these are considered pure substances. So a pure substance is a uniform composition where if you looked at these things on a molecular level, actually looked at all the molecules, they would have a constant composition. Water is hydrogen and oxygen, but they're always at a ratio of 2 H's to 1 O, and you're never going to find a variation in that. Okay, so an element and a compound are both considered pure substances. Then we get back into mixtures. So mixtures is the physical combination of 2 or more substances, right? We talked about. The main thing to realize about mixtures is to differentiate them from compounds. So as I've already said, a mixture is a physical combination of elements. A compound is a chemical combination of elements. And the big difference when you're working with these things practically is that mixtures can be separated fairly simply where compounds can't. And then the other thing in terms of like, how can I tell which is which? When you have 2 elements coming together to make a compound, they lose their individual properties to make new properties, where a mixture keeps their 2 inherent properties and just combine in one location. So for example, again with the water, hydrogen is a combustible gas, oxygen is a gas you breathe. When they come together, they make liquid water, which is very different in terms of all its properties. And you can tell there's a difference. Talk about a mixture, we can talk about Kool-Aid, for example, is a great mixture. You're taking water and you're taking the Kool-Aid powder and you're mixing them together. Once they come together, the Kool-Aid powder doesn't lose its inherent property. It's still usually the same color as that powder. It tastes like the sugar of the powder. And the water doesn't lose its property. It's still wet. It's still a liquid. You just have both things in one location. Okay? So that's the difference between a compound and a mixture. The other thing is a mixture is not a pure substance. So if you looked at a mixture on a microscopic level, you would see that you have a variation in composition within the substance. Therefore, it's not pure. Okay, pure is always going to have one uniform thing consistently repeated throughout the substance. Now in terms of further classification of mixtures, we have homogeneous mixtures and we have heterogeneous mixtures. So when 2 things physically combine and that combination looks uniform in composition, that's called homogeneous, meaning same. Okay, everything looks the same throughout. If you have 2 things physically combined and they don't look uniform, they look lumpy, there's inconsistencies, there's area you see more of one than the other, that's heterogeneous, which means different. Okay, so an example of heterogeneous: sand in water, flour in water, anything lumpy or clumpy, okay, that would be heterogeneous. Homogeneous, on the other hand, is any of that sugar or salt in water where it actually dissolves and you can't see it anymore. Eventually, way later in chemistry, we'll talk about dissolving, and that'll be one of the key characteristic difference between a homogeneous mixture and a heterogeneous mixture. So just like you can further classify mixtures into homogeneous and heterogeneous, there's other words that we can use to classify matter. One word is an alloy. Alloy is a very specific type of mixture. It is a homogeneous mixture of metals. Okay? When you're dealing with things like bronze, stainless steel, sterling silver, those aren't one pure metal. They're not all silver or all copper. They're a mixture of 2 or more metals that have come together. They've actually come together into a solution and it's uniform in composition. Okay, so when you're dealing with a metallic alloy, that is homogeneous, totally uniform. Okay, and you should know this when you think about if you've seen bronze, or you've seen a penny, or you've seen jewelry that was silver. Those are all homogeneous mixtures. They're completely uniform, but you can re-separate them. The term solution is something to also be aware of. It's a further classification of a homogeneous mixture. Okay? It's usually a liquid. We'll get more specific on what a solution is later in chemistry, but a solution is another term for homogeneous mixture. Okay? Not every homogeneous mixture is a solution, but every solution is a homogeneous mixture. And then I've already mentioned pure substance, that a pure substance is just something that has a uniform composition and is also one thing consistently throughout. That's the end of video number 1. Make sure you've taken notes on the terms so that you're ready for an activity we're going to do tomorrow. Go ahead and complete the form and have a nice night.